Today we're going to be going over the complementary property of trigonometry for the 6 respective trigonometric functions of sine, cosine, tangent, cotangent, secant, and cosecant. But before we do and derive each of their respective terms, we must review the quadrants and in which quadrants are in which of the trigonometric functions positive and negative. Within the first quadrant, which is between the angles of 0 and 90 degrees, or 0 and 2 pi over 2, all of the 6 respective trigonometric functions will be positive. Within the second quadrant, only the sine function and the cosecant function will be positive, where theta, the angle, will be between pi over 2 and 90 degrees and pi, 180 degrees. Within the third quadrant, only the tangent and cotangent functions will be positive, where the theta angle will be between pi, 180 degrees, and 3 pi over 2, or 270 degrees. Lastly, within the fourth quadrant, being the only cosine function and the secant function being the only two positive functions, with theta being between 3 pi over 2, or 270 degrees, and 2 pi, 360 degrees. All angles furthermore greater than 2 pi will be another revolution of 2 pi, which will result back into one of the quadrants. And you might be wondering how I derived, or not derived, but accumulated these results. Well, you can find them out through the respective graphs of the trigonometric functions. And those graphs will tell you exactly in which of the theta angles will be positive and which theta angles will be negative. But moving on from that, we're primarily focused on the complementary property for in this video. But how do we approach sine of pi over 2 plus theta? Well, for our memorization purposes, we can think of the angle theta to be a very, very light nudge other to 90 degrees, or pi over 2. So let's say we have this angle right here. We have this angle. Well, this angle, we know that angles always start from the x-axis going counterclockwise to here. This will be theta. And let's say in this example, theta is 90.0001 degrees. Well, that is extremely small change, 90 degrees. But yet, this angle will now result and lie within the second quadrant, where, as based on the trigonometric rules and functions, have told us that only the sine and cosecant functions are positive within the second quadrant, where the angle is between pi over 2 and pi. Therefore, the sine of pi over 2 plus theta's result will remain a positive. Likewise, for the cosecant function, its reciprocal will also, likewise, the sine remain positive. But the complementary property states that the trig of pi over 2 plus minus theta will be equal to the plus minus of its cotrig theta. And what do I mean by cotrig? Well, that is the complementary of sine. And the complementary trigonometric function of sine is the cosine function. So this will be equal to the positive cosine of theta. And before we move on to cosine, let us move on to cosecant. What is the complementary function for cosecant, or the co of cosecant? Well, the co of cosecant is the secant of theta. And as we know that the secant function is positive within the second quadrant, and that for any slight nudge for an angle like 90.0001 degrees will result in the second quadrant, or result in a positive the cosecant function, which from the statement of the complementary property will state that the trig of pi over 2 plus theta will be equal to the cotrig of theta. Therefore, secant of pi over 2 plus theta will be equal to the positive of secant theta. And then moving on to the respective else of the 4 other trigonometric functions. The cosine, tangent, cotangent, secant functions within the second quadrant will be negative. That cannot be diffused, or it cannot be argued, because that will remain always as true. Therefore, we can safely put the negative symbol in front of each of the results of the remaining 4 trigonometric functions. And likewise for the sine and cosecant, how we did it for those, we must find the co of cosine. Well, the co of cosine is just sine of theta. The co of tangent will be the cotangent function. The co of cotangent will be the tangent function. And the co of secant will be cosecant. And notice how within sine of pi over 2 plus theta, cosine of pi over 2 plus theta, etc., we have the two respective alternatives, or reciprocals of one another, being cosine and secant of theta. These two are reciprocal functions of one another, and yet they are the two resulting functions which are positive. The rest being negative. And with that out the way, we can move on to the sine of pi over 2 minus theta and the trig of pi over 2 minus theta in general. Well, instead of moving forward, when we subtract an angle from pi over 2, we'll be moving backwards in a way, or clockwise, to the first quadrant. So think of it as an extremely slight nudge for memorization purposes to 90 degrees, such as 89.99999 degrees. Well, that is an extremely small difference to 90 degrees, but yet 89.9999 degrees will result an angle within the first quadrant. And as we all know, within the first quadrant, all of the 6 respective trigonometric functions will be positive. Therefore, we do not have to put any negative symbols in front of any of the 6 respective trigonometric function results, as the subtraction of theta from pi over 2 will always result in a positive outcome of the resulting function. Therefore, as the complementary property states, we must find the cotrig of the trig of pi over 2 minus plus theta. So this will be the co of sine, the cosine function, the co of cosine, the sine function, the co of tangent being the cotangent, the co of cotangent being tangent, the co of secant being cosecant, and the co of secant being cosecant, being secant of theta. And here we have proved and derived this 12 respective functions which are included within the complementary property of trigonometric functions. Where in the next video, we're going to be going over the supplementary properties.